The UART protocol is a very basic protocol. So if you are a fresher and you have no experience, no work experience, and you are applying for the new job opportunities, or you're waiting to join any company, or you're trying to join any company, then the first step is the you should know the UART protocol. So it is a very basic protocol. So the interviewer may ask or may not. It depends on it. But knowing about the protocol is important, because it will be used in the industry also. So knowing the protocol is mandatory. Yeah. So knowing the protocol is very important, because UART protocol is widely used in the industry also. In case I'm using UART protocol in my company only. I'm basically debugging my FPGA with the help of your protocol. Basically, we will connect our computer with our FPGA with the help of we have a cable called MOXA cable. So UART protocol will be implemented in that cable, and we will debug the code into that FPGA with the help of this UART protocol. So basically, this UART protocol is a very basic protocol. It is for communication. It is mainly for the communication of our peripheral devices with our system. So for communicating with our peripheral devices to our system, we use our UART protocol. It is basically used for communication between the peripheral devices. So basically, there are two types of protocols. First one is on-chip protocol, and coming to second one is peripheral protocols. So there are basically two types of protocols. First one is on-chip protocol, and the second type are peripheral protocols. So this UART protocol comes under peripheral protocol. So basically, we are going to see how this UART protocol is communicating with our peripheral devices, like how it is helping our peripheral devices to get communicated with the system. And coming to on-chip protocols, we have AMBA, AHB, AXI, APB, and we have some other protocols for on-chip protocol. Basically, they are communication. Basically, they are like a set of protocols to set the flow of data. So to how the data should flow between the different devices on the chip. Basically, an SoC, so system on chip. So basically, how the data should flow between the different devices in an SoC. This on chip protocols like AMBA, AXA, APB, HB will set a guidelines. And coming to this peripheral protocols, we have UART, I2C, and SPA. So these are the peripheral protocols. Is this clear? The difference, is it clear? What we are going to learn is clear?
Yes, sir.
Yeah. So
Yes, sir.
we are going to learn peripheral protocol. So this is this protocol will tell how the peripheral is getting communicated with our system. So in this course, what we are going is, first we will learn the advantages of a protocol, of this UART protocol. We will see what are the advantages of this protocol and what are the uses of this protocol, where we are using this UART protocol. So generally, in any, okay, so I want one confirmation. So how many are appearing for interviews? How many are trying for interviews? So that I will take the sessions in the point of interview point of view. So that's why I was asking that. Okay, so many of them are attending interviews. So I will take the sessions in the point of interviews. So I will include some interview questions also, so that it can be helpful. So okay, thank you. You can raise down your hands. Yeah. So in our sessions, we will discuss the advantages. So first we will discuss the advantages and uses of the protocol. So basically, the first question asked by the interviewer is, what is the advantage of the protocol, or what is the use of the UART protocol. He will directly ask the question, what is the use of the protocol. So if you don't know the use of the protocol only, then he will skip to the other questions. So knowing the uses of the protocol and advantages of the protocol is very important. So this is the first point we are going to discuss, and next we will go into the frame structure of the protocol. So next we will discuss the frame structure of the protocol, like what is the frame of the UART protocol, what are the fields the UART frame consists. Like in UART we have start bit, data, stop bit, parity. So we will discuss all those in the frame structure. So this is the theory part. So this is the theory part we are going to discuss in the UART protocol. So after this we are going to start with the Verilog coding for this UART protocol. So basically in Verilog coding we are going to develop a top module. So I'm going to briefly give the plan of what we are going to do. So this is a top module. We will develop a top module, and in this top module we will be having a sender.
Sharing your screen.
Oh, sorry. Thanks for the confirmation. Yeah, is it visible? My screen is visible, right?
Yes,
Yeah. Okay.
yes, yes, yes.
So first we are going to discuss about the advantages of the protocol and uses of the protocol. So after completing this, we will come to the frame structure of the protocol. So we will be discussing what is a frame structure. It is a very basic protocol. So the frame structure is also easy to remember, and it is a very easy frame structure compared to other protocols. Your protocol is since it is a very basic protocol, so it is very easy to remember. And this comes under theory part. So after this theory part, completion of this theory part, we are going to start with a Verilog coding. So in this Verilog coding, we will be developing a top module. In the top module, we will be having a sender. So this sender will all we will code this sender, and we will be having one receiver. So these two blocks we will be coding. So the sender will send some data to this receiver. So this receiver will accept the data, and it will give it to the top module. So we'll write a test bench for this top module, and we'll receive the data to our TB, and we will check it. So basically to this sender we will send the data, and from the receiver we will receive the data, so that we can cross check whether we are getting the data which we have sent or not. So we will send like some ASCII characters like A, B, C. So we will convert this characters. So I will show how to convert these characters into binary numbers. So we will convert the data to ASCII characters to binary format, and we will send those binary digits from the sender to the receiver, and we will collect it from the top to the TB, and we will check it whether we are getting the expected data or not. So I'm planning to use FSM style of coding. So basically where there is a complicated protocols involved, or where there is a complicated coding, we use FSMs for making it easy. So I'm going to use FSMs both in sender and receiver to get the code easy. So I will show how to use this FSM coding, and we will discuss it all. And the software requirements for this is you should have some simulators like Vivado, or model sim, or any other simulators. If it is there, then uh, it will be very helpful to practice also. So I won't be giving the code initially. So I won't be sharing the code initially, because if I share the code, then uh, I think there will be no practice. So I will show the coding, but I will share the code after the completion of entire course. Like after the completion of entire course, I will share the code. But during the course, I will not share any code, because you should also get some practice to the coding. So that's why I'm not going to share the code. So after the completion of the course, I will share the code. That's for sure. I will share the code. I will upload it in GitHub, not in the GitHub. So it will be public. So I will send in the Telegram. So that is the plan. And coming to system Verilog coding. So how many of you aware of system Verilog? Like how many of you are good at system Verilog? Is this okay?
How long your theory session will be there?
UART is a very
Uh,
small protocol, so it can be completed in 1 or 2 days.
okay, 1 or 2 days, every day, nearly 1 hour.
Not 1 hour, half an hour to 40 minutes.
Okay, okay. After that, Verilog coding.
Yeah, after completion of
Okay,
theory,
yeah,
we can code in Verilog.
okay, including FSM style.
Yeah, we will code the entire project in FSM style only.
Okay, okay,
I will show how to code in FSM
okay.
style.
And yeah, sure. Thank you.
Yeah, and one more thing I want to highlight is classes may be skipped like 1 to 2 days, like in between, because I have some other works, like I have some office works. If there are some office works, I will ping in the Telegram. So on that days we can skip the class. So maximum this course will be completed in 1 to 2 weeks, because this is a very easy protocol and we can complete it. And the Verilog coding also we can complete it in 3 to 4 days max. And the TB also I will show how to write the TB structure, entire thing. So if you are facing any doubts, or you are if you are facing any challenges in coding, you can ping me anytime. But I will reply only in evening times, like 7 to
Class, class, class will be in evening only, no?
yeah, class will be 8:30. That's fixed.
Okay, sure. Thank you.
Yeah. So that's the plan for the course, and that's what I have planned. So this is a PPT I have prepared for this UART protocol. So I will want to show this. I have prepared about the uses of UART protocol. So after completion of uses, we are going to learn about the UART interface. So basically, yeah, one more point I want to highlight is your protocol is learned by two streams of people, like embedded people and VLSI people. So embedded people will learn about the hardcore device, like what are the pins for it, and they will analyze the um, your device. So we are not going to do that. We VLSI people generally develop the logic for the communication, like how the data should flow, like that. Because we are RTL engineers, right? So register transfer level, we will be mainly focusing on the flow of data. So how the data should flow, how the data should transfer, like that. So we are not. So as discussed in yesterday's session, we will be discussing UART in multiple stages. Like first we will start with the advantages of UART, where we are going to use UART, and we will then discuss about the frame structure of UART, what are the fields present in this UART, and then we will start with the coding in Verilog. So coming to the UART, so the full form of UART is Universal Asynchronous Receiver and Transmitter. So the full form of UART is Universal Asynchronous Receiver and Transmitter. Wait a minute. So basically, in UART, it is a single master and a single slave device or protocol. So in UART, we will have only a single master and a single slave, and the communication is between the single master and the single slave. And in UART, we have a transmitter pin and a receiver pin. Here at the slave side also, transmitter and receiver. The terminology is master is given to a device which is sending data, and the slave is nothing but the device which is receiving the data. So the terminology of master and the slave is not fixed to a device. A device can be a master at some time and a slave, and it can be a slave at some other time. So don't fix any device or any peripheral as a master or slave. So it depends on the data flow. So if the device is sending the data from uh, so if the device is transmitting the data, then it becomes a master. If a device is receiving a data, then it becomes a slave. So many get confused in this terminologies. So don't fix any device as a master or a slave. So the terminologies are variable. So according to the data flow, the terminologies will get changed. Is this clear? So the name itself, UART stands for asynchronous receiver and transmitter. So in the name itself, you can see the keyword asynchronous. So in case of UART, we don't have any clock. So internally, we will be having one clock for baud rate generation. We will discuss the baud rate generation in upcoming sessions. So we don't have any shared clock between the master and the slave. So the data transfer between the master and the slave will not happen with respect to clock. So that's why this protocol is asynchronous protocol. Synchronous protocol means the data transfer is happening with respect to clock, whereas asynchronous means the data transfer is not happening with respect to clock. So that's why this protocol is asynchronous protocol. So the protocol is asynchronous, then how the data transfer is happening? So how the master and the slave are managing the loss, or how the master and the slave are preventing the data loss. So the master and the slave are preventing the data loss with the help of baud rate. With the help of baud rate. Since the master and the slave are asynchronous and they are not depending on the clock for data transfer, but the data is not lost between the master and the slave because of the concept called baud rate. We will discuss about this baud rate also. So remember this, there is no clock for the transfer of data between the master and the slave. Since the protocol is asynchronous protocol, so there is no shared clock for the data transfer. So the data transfer is happening without any loss with a concept called baud rate. We will discuss that baud rate. So UART stands for Universal Asynchronous Receiver Transmitter. This we have discussed, and it's a hardware device used for serial communication, commonly found in microcontrollers, computers, and other electronic devices. So the data which is sent by okay, so let's say this is our processor inside our system or some device. So this processor sends the data parallelly. So this is a parallel data which is coming out from the processor, and this processor wants to communicate with a peripheral device. This is a peripheral device attached with the processor. So if the processor wants to communicate with the peripheral device using the UART protocol, so what happens is this UART protocol, this UART device will convert the parallel data to a serial data, and it will give the serial data to our peripheral. So the peripheral will process the data. So since the peripheral will not have so much of memory and so much of capability to process the parallel data, so we use the UART protocol to convert the parallel data which is coming from the processor to a serial data, and the UART protocol will convert the parallel data to a serial data, and it will give it to the peripheral, and the peripheral will perform its necessary operations on the data, and it will give back to our processor if needed. If it wanted to give back the data to processor, then again the peripheral gives the data to the UART serially. So the input from the peripheral to the UART will be a serial data, and the UART then converts again the serial data to a parallel data, and it will give to the processor. So the UART converts the data from parallel to serial as well as serial to parallel. whichever it is necessary, it will convert the data from parallel to serial, or sorry, serial to parallel. So is this clear? This concept is clear?
Yes, sir.
So it's a hardware device used for serial communication, commonly found in microcontrollers, computers, and other electronic devices. So the UART facilitates asynchronous communication. We have already discussed this. So asynchronous communication means there is no clock involved for the transfer of data between the devices by converting parallel data from a computer or a microcontroller controller into serial data streams that can be transmitted over communication lines such as RS-232, RS-485, or TTL, or vice versa. So the output of the microcontroller or the processor will be a parallel data. So the UART will convert that parallel data to a serial data, and it will give it to a peripheral device. So that peripheral device will operate on the data. So coming to communication lines used in UART, we majorly use RS-232, which is a communication line. It is a standard for transferring of data. So you can refer this. RS-232 is a standard for serial communication transmission of data. So it defines the electrical characteristics of the signals, the timing of the signal, and the format of the data, and more. So RS-232 is commonly used for connecting serial devices such as modems, printers, scanners, and various other peripheral devices to the computers. So for connecting our UART device to a processor, we cannot simply connect it to our processor. We use some standard set of protocol. Here in this case we use RS-232. It is a standard serial communication protocol. We use that and we connect that UART to our processor or microcontroller. So this communication we use. And now coming to uses of UART. So UART is a fundamental component in digital communication systems, enabling serial communication between electronic devices, which we have already seen. So for example, if we want to connect a mouse to a system, then we use UART protocol for connecting our mouse to. We use UART protocol. Mouse is also a peripheral, so we use UART protocol for connecting that mouse to the system, or keyboard. Keyboard is also a peripheral, and we use another protocols also, but UART is also a protocol which is used for the transfer of data. So uses of UART is interfacing with peripheral devices, wireless communication, control and monitoring systems, and industrial automations. So we interfacing with peripheral devices, which we have already seen. The one of the primary uses of UART is to interface the microcontrollers or computers with the peripheral devices that communicate via serial protocol. For example, we have a connecting a microcontroller to a sensor such as temperature sensor, humidity sensor, or accelerometers. The best example to understand this UART protocol is Arduino board. So I hope you are aware of this Arduino board, right? Yeah. So, in case of Arduino board, when we connect any peripheral devices like sensors or temperature sensors, humidity sensors, so the communication between the Arduino board processor and the peripheral will happen using this UART protocol only. So the UART protocol is used for this communication. So in interviews, you can answer this question: what are the uses of UART? Give some practical examples, then you can answer all this. So try answering for at least 2 to 5 minutes, then it will be, so they will come to know that you know the applications more clearly. And we can also communicate with GPS modules for location tracking applications. Basically these peripherals all these peripherals can manipulate data when the data is given. Basically these peripherals will operate on serial data only. They cannot operate on parallel data. So but the processor is giving the parallel data as the output. So these peripherals cannot operate directly on the parallel data. So we are using UART protocol for converting those parallel data to a serial data. And interfacing with RFID readers for access control systems or inventory management. This is also one of the application. And wireless communication, UART is also often used in conjunction with wireless modules to establish communication between the devices wirelessly. And connecting to a microcontroller to Bluetooth modules for wireless. So UART is mainly used in IoT devices also, and utilizing UART with Wi-Fi modules to enable IoT devices and controlling and monitoring systems. UART is frequently employed in control and monitoring systems. So these are some of the applications. We can also microcontrollers in case of Arduino only. We can connect um, motors as a peripheral devices to the Arduino, and we can send the PWM signals, pulse width modulated signals to that motor through that Arduino board, and we can control the speed of the motor. So here the signals are transferring to the peripherals using the UART protocol. And we can also establish the communication between the microcontrollers and display modules for information display. And in case of embedded systems, this is a very important point. This we will be using in our industries also. So in case of embedded system development, UART is a vital tool in embedded system development for debugging and programming microcontrollers. So I will show one example here. Yeah, connecting microcontrollers to computers via UART for programming firmware or bootloading. And using UART for serial debugging, enabling developers to print debugging messages and log data from microcontroller to computer terminal. So this is a very good example. So when we are using FPGAs, I think you all know about FPGAs, right? Yeah. So while using FPGAs, we generally write the code in Verilog or VHDL in some tools like simulator tools, and we synthesize the design, and we generate the bit stream after completing entire synthesizing entire code. We will generate some bit stream, and using the JTAG cable, we will dump this bit stream to our FPGA. And say suppose there are some processors like Zinc FPGA, or there are some processors like Microblaze. Sorry, this is a FPGA, Microblaze and Zinc FPGAs. So in this FPGA, say in case of Zinc FPGA, wait a minute, listen this carefully. This is a very important point where we use UART. So this is a Zinc FPGA, and in Zinc FPGA only, it is partitioned into, while chip fabrication only, the manufacturers partition this Zinc FPGA into two parts. That is, one is programming system and programming logic. So in the Zinc chip only, we will be having one processor and a FPGA fabric. So this is a FPGA fabric where we write our Verilog code or VHDL code, and we dump our logic into this programming logic using the JTAG interface. And this is a processor. This is a processor. So after uh, developing our FPGA fabric, what we do is we will write a C level language. We will write a code in C level language in SDK, which is called Software Development Kit. So basically, we will program our processor. We will program our processor also in the SDK, and we will drive the inputs from the processor to programming logic, and we will observe what's happening in the programming logic with the help of SDK. So we will connect one USB port or UART port to this, and we will send the commands one by one using this UART cable to our processor, and the processor will feed our programming logic and the programming logic will give the necessary outcomes or expected outcomes, and this will be displayed again by using UART cable, and it will be displayed in our SDK. So like this, we will code our FPGA, and we will analyze our outputs using the FPGA and UART. Is this example clear? So basically in industries, this is what we are doing uh, if we want to use FPGAs. Is this clear? Is this example clear? Yeah. For others, is it okay? Yeah. So these are the some of the examples of UART. So applications of your UART also are also very important. So please remember these applications, and we will start a basic intro of this UART interface, and we will end the session. So the basic pins of a UART, as already discussed, are receiver pin and a transmitter pin. Receiver pin is used to receive the data, and transmitter pin is used to transfer the data. And here this is a master and this is a slave. If UART1 is sending the data to UART2, then UART1 becomes a master and UART2 becomes a slave. And if UART1 is receiving the data and UART2 is sending the data, then UART1 becomes a slave and UART2 becomes a master. So this is how a master and a slave are formed. And here we can see there is uh, there is only one master and a one slave. It cannot be multi master and multi slave. In UART protocol, only one master and one slave is used, whereas in other protocols like I2C we can have multiple masters and multiple slaves. So in UART interface we will have only one master and one slave. And we have already discussed the parallel to serial conversion. We will discuss this parallel to serial conversion and serial to parallel conversion. And yeah, so we will end this session with this. So in tomorrow's session we will discuss about what is baud rate, uh, how this is helping uh, for the transfer of data without any loss. So after completing this baud rate, we will start with the UART frame structure. So this is a UART frame structure, we will discuss it. And after that, we will see how to transfer the some of the ASCII letters like W or a G. So for this ASCII letter, we will have some binary value. So we will convert this ASCII letter to this binary value, and we will try to transmit it, and we will try to receive it. So after completing this example, we will start with the Verilog coding of this UART sender, UART transmitter, receiver, and baud rate generator. So after that we will write the test bench for that. So this is the plan. So that's all for today's session. If you are having any doubts, you can ask me, or else we can end the session.